there is a call from WHO for the elimination of cervical cancer by 2030 or to bring it down to very low levels. And hence, the mandate is to screen more than 70% of the women should be screened. More than 70% of the women should be vaccinated, and those with the disease should be given appropriate facilities, should be enhanced for providing proper health care to individuals who are affected with the disease. So we are employing genomics to do our best to understand what are the genetic factors that could modulate disease development. So our focusing on cervical cancers, we started initially to look at individuals having the same cancer, say stage 2 cervical cancer, and you offer them the standard treatments that are available. You would see that the response of the two individuals would be different. One individual will be responding very well, the other individual might not respond that well. So what is the underlying basis of differences in the response? So this can be explained through looking at genomics. So this way one needs to identify what are the subtypes which exist in the cancer. So to do this, in case of cervical cancers, we focused our work on HPV-16 positive cancers because of the fact that HPV-16 is the most predominant type in cervical cancers. So what we did, we first showed that majority of the cancers in India are slightly different from what we observed in the Western countries. Over there, the reports are that HPV integrates and then brings about transformation of the cervix. But in India, what we have seen is that our study, as well as there are other reports which show that the virus exists in the episomal form in majority of the cancers, in more than 60% of the cancer cases. And these cancers have a very typical phenotypic characteristics. The viral copy numbers are very high compared to the cancers which have integrated viral genomes. The expression of viral E7 oncoprotein is also very high, and we also see expression of the repressor protein E2. But if the repressor protein is expressed, how could the cancer develop? Without, if the repressor is expressed, then it is expected that the oncoproteins will not be expressed. However, the oncoproteins are also expressed along with the repressor. So we conducted studies also to identify what are the causes behind this, and we identified several genetic variations which prevent the repressor protein from binding to the regulatory region of the virus to implement its activities. And then we also looked at the cervical cancers which had integrated viral genomes. Even within those cancers, we were able to identify 4 subgroups, and each subgroup was characterized with different levels of the viral oncoprotein as well as viral genome copies. So taken together, we think that these two types of categories of cancers are likely to be different. They are different at the molecular level, and therefore this might translate into altered response of these cancers to therapy. Therefore, one needs to think of identifying appropriate suitable therapy for targeting these cancers. Likewise, we also looked at the viral intratype variants. Initially, we used Sanger sequence-based techniques to identify the variations. HPV-16 exists in multiple forms. There are 5 forms in which HPV-16 exists, and each of these forms they have been identified to be different at the molecular level in terms of their oncogenicity, and therefore we also identified several interesting findings to differentiate between this. In our population, we found that the European variant was the most prominent type, and there were some Asian American variants identified. But normally it was thought that Asian American variants were more virulent than the European types. But what we saw is that majority of the cancers harbor the European type. So the European type is equally virulent as the Asian American type as well. Having done this, we then moved on to do the whole genome sequencing of the virus HPV16. And after doing this, we were able to identify the classification of the viral variants changed subsequently, and it was found that based on whole genome sequencing, there were 10 sublineages that could be identified. And what we saw after doing whole genome sequencing is that there are two major sublineages in cervical cancers in India. The one is the sublineage A1 and the other is sublineage D1 and D2, which is a smaller fraction. So again, these two types were characterized by typical phenotypic features. The A1 types had high copies of episomal viral genomes and high expression of the E7 autoprotein. And whereas the other types did not have these. So taken together, again, our data reflects variable outcomes with respect to disease prognosis and therapy response. Then we did also many other kinds of studies through which we were able to identify HLA variations like we